Hello, welcome to week 2 of the semester. Hopefully you made it out relatively okay. I know it was a tough week for a lot of the faculty, and I can't imagine what you guys are going through. But I want to say thank you for your patience. I know that last week we had a lot of things go wrong, and I think that it's going to get smoother as we progress and get more familiar with the technology and what works and what doesn't. So an overview of this week. This week, both days, Tuesday and Thursday, are going to be focused on Chapter 57. So in this first lecture, it's going to be focused more on me talking about the material. And then in the lecture on Thursday, we will try again to do another activity. And I will do a little test run before that on how to create documents that you guys can share. And so hopefully some of you were able to get in touch with your groups. If you weren't, or if you didn't try to, this is going to be another chance for you guys to connect. So chapter 57, we're talking about the biosphere. And you may wonder, we were talking about molecules and cells and atoms last week. Why are we talking about the biosphere, like the biggest level of, categorizing life? Well, what we're going to be talking about today is weather, and we're going to be talking about different cycles that occur on Earth. So things like the carbon cycle, the water cycle. And so just like atoms of carbon are important for creating molecules essential for life of cells, these things elements such as carbon, phosphorus, oxygen, hydrogen are also important for creating the environments that all of these living things exist in. So we're going to go over a few different objectives for this chapter. Again, these are what you should use when you're studying to help kind of prioritize. First, you should be able to understand the global and local processes that determine environmental conditions at a certain place. Second, you should know the principal biomes and their defining characteristics. The third objective is to be able to characterize the factors that determine oxygen levels in freshwater habitats. Fourth objective is to understand how primary productivity is varied in different marine ecosystems. The fifth objective, know how different ecosystems are impacted by human pollution and resource depletion. And lastly, we'll be talking about carbon dioxide in the atmosphere and how that can affect temperature and global warming. So let's start with the first objective. So we're going to be talking about global and local processes that determine environmental conditions at a certain place. So basically, why is it that we have kind of a temperate climate here, but up at the North Pole it's very cold, and in the tropics it's very nice and warm and humid? Those types of questions. So the big things that impact the climate and what can live in a certain environment are going to be sun, wind, and water. So again, the biosphere is basically, it includes all living communities on Earth. We're going to be looking at global patterns of weather first. And so these global patterns of weather are going to be affecting the type of life that exists around the world. So these organization of living things on the Earth is determined by climate. And climate is determined by, first, the sun, the amount of solar radiation that reaches different areas. And then second, we're going to talk about that wind, global atmospheric circulation. And so these patterns of atmospheric circulation also affect oceanic circulation. And we'll talk about that. So let's focus first on solar radiation. Here we have a picture of the Earth, and we're imagining that the sun is to the left of it. And you can see the sun rays hitting the Earth. And notice that around the equator, the sunlight is hitting the equator perpendicularly, right? Straight on. And the surface of the ground that is getting hit by that is kind of like a small circle, right? However, if you look very far up north or south of the equator, you can see that the angle that the light is hitting the Earth is not perpendicular, it's quite flat, right? So there's a steep angle. And what that does is the area of Earth that is covered by that sunlight is much larger. So you have the same amount of sunlight coming from the sun at all these different levels, but you've got more sunlight, more beams of light striking at the equator in a smaller area, whereas that same amount of energy is hitting in the North and the South Pole over a larger space. And so all that energy is kind of diffused across this larger area. So some parts of the Earth's surface are going to receive more energy from the sun. The more perpendicular they are to the sun's rays, the more concentrated the light is in that area. So I actually had a misconception about how this works. I always thought that it was because the equator stuck out more and it was closer to the sun, and so that's why it's warmer. Probably does not make that much of a difference in terms of starting in the center versus, let me get a little highlighter here, this distance versus this distance. Probably doesn't make too big of a difference. But when you're looking over here, it's not flat, right? And so you've got a larger area that's being hit by the same amount of light as this small area. And so the angle is really what is making a big difference here. So this is called the angle of incidence. How the sun's rays strike the spherical Earth. The fact that the Earth is a sphere means that these straight rays of light are going to hit it and be dispersed in different ways depending on where it hits this sphere. So again, here we have near the equator, the sun's rays are hitting it at a perpendicular angle, but the further north and south you go, the light's hitting the Earth in a more angled manner. In addition to the spherical nature of our planet impacting the weather, climate, in terms of the spherical nature of the Earth in impacting how the sun heats it, we also have the Earth's orbit, and we have a bit of a tilt on the Earth's axis. So here we have on the right, we can see sun is in the center, and we've got the Earth rotating, orbiting the sun. And we can see that, for example, at vernal and autumnal equinox, that the sunlight is hitting exactly at the equator. However, because the Earth is tilted on its axis, here you can see it's not straight up and down, that means that at some times of the year, the northern hemisphere is going to get hit with that perpendicular ray of light, and other times of the year, the southern hemisphere is going to be getting more of a perpendicular ray of light. So here we're seeing the fact that the Earth is on its angle, and the fact that it is orbiting around the sun is starting to cause seasons. So on the first slide that we looked at, just having the Earth being a sphere is going to affect the climate basically at the equator versus the North and the South poles. And now we've got the angle of the Earth and the fact that it's orbiting the sun is causing seasons. So this tilted axis and the fact that it orbits, it has a big effect on seasons. Depending on the time of year, different regions have more direct angle with the sun. So now we're going to watch a little video. I think that, we're kind of getting into astronomy, right? And so I really liked this video that talks about differential heating. It talks about why the equator is warmer than the North and the South Poles, and it breaks up some interesting concepts.